So we discussed about anomalies due to interleave execution of transaction. Due to interleave execution of transaction, we have some anomalies. So those we discussed. Mainly those are reading uncommitted values. Second one, unrepeatable reading data operation. Third one, overwriting uncommitted data. Overwriting uncommitted data. So what are the anomalies due to interleave execution of transactions? Mainly three. What are the problems? Reading uncommitted values. While reading uncommitted values. Second one, unrepeatable reading data operation. Unrepeatable reading data operation. Third one, overwriting uncommitted data. Overriding uncommitted data. Overwriting uncommitted data. First one, reading uncommitted values. So here we can say write read conflicts. You can say what is that? Write read conflicts. We have written here, right? Write read conflicts. So that is also called as the T-read operation. The T-read operation. See here we have two transactions, T1 and T2. Okay. See, without committed here, without saving here, we are committed here. See, we are doing read operation, write operation on A object. Okay. And in T2, we are reading A object and writing A object, then reading B object, writing B object, then committed. Here, reading B object, writing B object, then committed. So we are reading uncommitted data. See here we read A object, write A object. Here we doesn't commit anything. Okay. But in T2 operation we are accessing that value. In see here in above example T1 write operation on the data item A is not committed, but it is being read by T2 operation, okay, T2 transaction. So reading an uncommitted data will leads to inconsistency in database, which is called the T-read operation. You understand? We have two transactions, T1 and T2. We are performing read and write operations. So we have objects A, B here. Reading data item A and writing data item A. Here we doesn't do any commit operation, but in T2 we are accessing the data. So accessing that data item. So without committing, you are doing is at the uncommitted data will lead to inconsistency in the database. So which is called the T-read problem. That is called the T-read operation. The second one is unrepeatable reading data. Unrepeatable reading data operation. That is also called read-write conflict. That is also called read-write conflict. Reading the same object twice before committing the transaction might yield an inconsistency. How we are getting inconsistency here? Reading the same object twice. We are reading same object twice before committing the transaction. Before committing the transaction, we are twice. We are reading same object twice. So that here we can call inconsistency. So that we can call here unrepeatable reading data operation. So RW means read write conflict. Reading same object twice before committing the transaction. That means before committing the transaction, before saving updated data into the database, we are reading same object twice. That is called inconsistency here. That is inconsistency here. That we can call is a anomaly. That is a problem here that we consider as unrepeatable reading data operation. Read write conflict. Then the third one is what? Overwriting uncommitted data. Write write operation, also called as blind write conflict, also called as blind write conflict. Blind write conflict. See, in unrepeatable reading data operation, in unrepeatable reading data operation, reading same data object twice before committing the transaction might yield a inconsistency. How it is? So if we take one problem here, first in read write conflict, first read then write conflict, write after read. That means what? Write after read. If you read first only, then we can write that value. Okay. So unrepeatable problem means, here unrepeatable problem means we get different values in different reads, different values from different reads. For example, in T2 read initially x value 5. Okay, from T2 transaction we reading x value 5. Then T1 updated x equal to 1. So now T2 will read x equal to 1. Here T2 has read two different values during consecutive reads. This should have been allowed as T1 has not committed. T1 has not committed. If that T1 is committed means that value fixed, right? That value is saved into later, then you can get that value. So that's we call unrepeatable reading data operation. The third one is overwriting uncommitted data. So that is called write conflicts. So we are writing double done. Now write conflicts. If one transaction could overwrite the value of the object A, which has been already modified by other transaction, while first transaction still in progress. This kind of conflict referred to blind write conflict. It's also called as blind write conflict. What are the third conflict? What is the third anomaly? Write write conflict. That means overwriting uncommitted data. Overwriting uncommitted data. How? If the conflict, if one transaction could overwrite the value of object A, okay, which has been already modified by other transaction, while first transaction in progress, first transaction in progress, if one transaction could overwrite the value of the object A, which has been already modified by another transaction, then this we can call as blind write conflict. Blind write conflict. So these are the anomalies. These are the problems. The next chapter is, next thing, recoverability. Recoverability. Recoverability and recoverability schedule. In that, irrecoverable schedules, recoverable schedules with cascade rollback, cascade-less recoverability. These things we are going to discuss now. Okay, here the recoverability refers to the process of undoing the changes made to the database in case of any transaction failure due to the system crash or any other reason. So when we are going to do recoverability, if the transaction, the recoverability refers to the process of undoing the changes made to the database in case of any transaction failure due to the system crash or any other reason. We follow recoverability. See, recoverability schedule. How we can do the recoverability? By using recoverability schedule. That recoverability schedule also classified into three ways. So based on whether recovery of failure transaction schedules are classified as three ways. First one, irrecoverable schedules. Second one is recoverable schedules with cascade rollback. Recoverable schedules with cascade rollback. Third one is what? Cascade less recoverability. Cascade less recoverability. So the recoverability schedule is classified as three ways. First one is irrecoverable schedules. Okay, that means we cannot recover. Second thing, for recoverability, first if when the data is irrecoverable, when data we can recover by using cascade rollback. When the data, some data we can recover and some data we cannot recover. Those three ways we can say in recoverability schedule. First one is irrecoverable schedules. Second one is recoverable schedules with the cascade rollback. We can recoverable by using cascade rollback. Next, third one is cascade less recoverability. Cascade less recoverability. First one is irrecoverable schedules. That means schedules which cannot be recovered. Schedules which cannot be recovered. Recoverable schedule means what? Schedules which cannot be recovered. Which cannot be recovered. So see here, if we have a transaction T2, that T2 reads the value updated by transaction T1. Then the T1 followed by write operation that is committed, then this schedule is called irrecoverable schedule. So if the transaction T1 failed before the committing, so transaction is failing right before committing, so that's we can call irrecoverable schedule. So irrecoverable schedule means schedules which cannot be recovered. Schedules which cannot be recovered. We cannot recover it. When the transaction T1 reads the value updated by transaction T1, if the transaction T2 reads the value updated by transaction T1 followed by the write operation commit, then this schedule is called irrecoverable schedule. When we can say irrecoverable schedule, we have transaction T1 and T2. If the transaction T2 reads the value updated by the transaction T1 followed by the write operation committed, then the schedule is called irrecoverable schedule. If transaction T1 failed before committing, so then we can say it is schedules which cannot be recovered. The second one is recoverable schedule with cascade rollback. Recoverable schedule, you can recover it with cascade rollback by using rollback operation. So we can say schedules which can be recoverable. That means we can recover it. The schedule we can recoverable. See, we have a T1, T2, two transactions. Okay. So if transaction T2 read the value updated by T1 and commit of T2 is delayed till the commit of T1, it is called recoverable schedule with the cascade rollback. We can recover it by using cascade rollback. By if the transaction T2 read the value updated by T1 and committed of T2, we are committing, committed of T2 is delayed till the commit of T1. That means what? If you committed T1 only, then we can read the T2 value. T2 can read a T1 value. So that's why it is still waiting, right? That means we can recover it because we are committing T1. Then only T2 can read the T1 value. So thus we can call recoverable schedule with the cascade rollback. So cascade rollback, by using cascade rollback we can do it. So we can roll back, then we can commit the T1 transaction, then that value can read by T2 transaction. So we can recover it. What is a recoverable schedule with cascade rollback? If transaction T2 reading a value updated by T1 and commit of T2 is delayed till the commit of T1. So that means what? Commit of T1 is waiting till the commit of T1. So it is called recoverable schedule with cascade rollback. With the cascade rollback. So we can recover it. In previous we can do the second way completed. Then third way is cascade less recoverability. We can recover something but not more. So some data only we can recover. How? It refers to if T2 read value updated by T1 only after T1 is committed. It refers if T1 read value updated by T1. So T2 here read T2 transaction reading the value from that T1. When only after T1 is committed, only after T1 is committed only we are reading the data from T1 operation. T2 reading the value from T1 when the T1 transaction was committed. So then we can call it as a cascadeless recoverability. Okay. You understand, right? Implementation. So these things: recoverability schedule, irrecoverable schedule, recoverable schedule with cascade rollback, and cascade less recoverability. So these things you understand. See here, the next one is implementation of isolation. ACID properties. In that isolation, implementation of isolation. Isolation means what, ma? T1 and T2 transactions. Not only T1, T2 and T3. So all are parallel transactions. Parallel transaction. How you can handle? Okay, with successful manner, how you can handle the transactions. So we are using serializability. Serial allow only one transaction. After T1 done, T2 done, then T2. So how to implement that isolation process we can see here. In two ways. First one is what? Access to shareable resources should be ordered by using locking mechanism and locking protocol. So access shareable resources should be ordered by using locking mechanism and locking protocol. After that, we will discuss about the transaction control commands. This we already discussed. We executed this queries also. Committed, save point, rollback. Then we will see the preceding graphing, serializability. We have algorithm in that with the three conditions: condition 1, condition 2, condition 3, and then we will see the preceding graph. Okay. See, implementation of isolation. How we can do implementation of isolation? See, when more than one instruction of several transactions are being executed concurrently by using some shareable resources, the execution of instruction of one transaction should not interrupt the execution of instruction of another transaction. So how we can implement it when we are handling this? So when more than one instruction of several transactions are being executed concurrently, we are executing several transactions concurrently by using some shareable resources. From shareable resources, we are executing some transactions concurrently. The execution of instruction of one transaction should not interrupt execution of instruction of other transaction. So one transaction is being executed, so other transaction should not interrupt the transaction. See, isolation means what, ma'am? We are performing several transactions: T1 transaction, T2 transaction, T3 transaction. Those are performing in parallel way, right? So in that situation, so if one transaction should not interrupt another transaction, one transaction should not disturb another transaction. That how we can implement by using two ways. First one is access to shareable resources should be ordered by using some locking mechanism. We are performing locking here, locking mechanism. Access to shareable resources should be ordered by using some locking mechanism. So how it is, where one transaction locks the shareable resources before starting its execution, and the release the lock to other transaction after completion of its execution. Thus we can call as locking mechanism. So by using that locking mechanism, so we can implement isolation process. See, first one is what? Access to shareable resources should be ordered by using some locking mechanism. How? When one transaction locks the shareable resources before starting its execution, and the releases lock other transaction after completion of its execution. So if one transaction is going on, so other transaction trying to implement. So what we are doing first, if the first transaction completes only, we are allowing the other transaction. That's what we are doing here. Okay. Next, by using locking protocol. What we are doing in locking protocol? Second one is what? Locking protocol. How we can do locking protocol? So locking mechanism can be implemented by using locking protocols, which define set of standard rules based on which transaction access in the shareable resources. By using locking protocols also we can implement the isolation. So how the locking mechanism can be implemented by using locking protocols. Through the locking protocols, we are implementing locking mechanism. So which define the set of standard rules. That means it contains set of standard rules based on which transaction access. First, which transaction we need to access in the shareable resources. That's we are giving the priority here. That's what locking protocol. Okay. In the two ways we can implement the isolation. See here, transaction control commands support with the SQL. How to control the transaction? By using transaction control commands. You know, right? Queries transaction control language. This is the sub language of SQL, structured query language. Those are what? Commit, save point, rollback. Here commit means what now? Transaction control command support with SQL. Commit, save point, and rollback. Here commit means what? Miss all of you. We already discussed these things. Commit, save point, rollback. Can anyone reply? Yes, all of you. Are you getting my voice? See, in transaction control commands supported with SQL. So what are those commands? Transaction control commands: commit, save point, and rollback. Commit. What is the use of commit? Commit. Commit means we are saving changes permanently. We are saving the changes permanently. If you do any modification in your table and if you committed, then only it is going to be stored permanently. Otherwise, if you do rollback something, it is going to be deleted. It is not available. You should save it. You should save means here commit. If you want to permanently save it, you should use commit command. Okay. Next to rollback. Rollback means what? Rollback. For doing undo operation for single step. See, for example, you have written one query called update query to update the salary of the employee. Then after that you have done some other operation. So I want to roll back when you updated the salary of the employee. So one step means we can roll back it. Roll back means we can do undo operation, control Z. We can do undo operation for single step. So coming to save point, for example, you are doing number of operations. I want to go for particular operation. If I want to go for particular operation, I want to mark that operation. To marking it, what we should do? We should save that operation with one point, the saving point. So we are using saving point, save point name. So with that operation, so by using that save point, we are going to roll back save point name. If you give like that, we can roll back to particular operation. That is the use of save point. These commands we are using in transaction control logins. To control the transactions, we are using these commands. Are you understanding? In shortcut way, you can say what is commit. Commit means we are saving all the changes permanently. Save point means which marks the particular operation. We can roll back it particular operation. For going for particular operation, we can mark it by using save point name. We can go for particular operation. That is what is the use of save point. Then coming to rollback. Rollback means we can do undo operation, control Z operation. We can go for single step. So that's what rollback. Okay, if I committed once, can I roll back it? No, we cannot roll back once if you perform commit operation. Commit means what? You are permanently saving all the changes. Then if I am trying to roll back it, that will not be work. That will not be work. So those important points from commit, save point, and rollback commands where we can use. So if I want to control the transaction, then I can use these commands in SQL. Next, those are from transaction control commands. The next thing is preceding graph in serializability. This is graph. Says graph in serializability. So this is the methodology perform serializability. We have this algorithm. This algorithm contains okay. By using this, we can draw the preceding graphs. Is it serializable or conflict serializable? We can know it by using these conditions. What is the algorithm here? First thing, create a node T and the graph for the each participating transaction in the schedule. T1 node, T2 node, T3 node, and Tn node. And so on. Okay. So draw edges for the transaction to another transaction when satisfy any one of the following. So these are the rules now. If we satisfy these rules, then we can draw the edges. T1 to T2, T2 to T3, T2 to T1. How we can draw it? By using this condition. If we satisfy this condition, we can draw like that. See here, if T1 execute write operation, see here we have read and write operation. For example, T1 and T2, we have two transactions. In T1 execute write operation, T1 performing write operation on something. T1 perform write operation, so write of X. Okay, followed by T2 executes the read operation, that is read X. T2 performing what? Read operation. So then we can write. So T1 to T2 we can draw the edge. So see the condition. If T1 execute write operation, T1 performing write operation, and T2 performing read operation, that is followed by T1 and T2. So T2 executing read operation, then we can draw the edge. We can draw the edge from one transaction to another transaction. Okay, this is first condition. Second condition, when T1 execute read of X, T1 execute read of X, followed by T2 execute write operation, followed by T2 execute write operation. Then I can write T1 to T2. Then I can write T1 to T2. Already there means we don't need to write. Next. third condition. What is the third condition? See, first condition is what? T1 performing write operation and followed by T2 performing read operation. Then we can draw the edge. Second condition is what? T1 performing read operation followed by T2 performing write operation. Then we can draw edge. Then third condition, when T1 executes write of X, T1 executes write of X followed by T2 write of X. Here T1 execute write of X, okay, then followed by T2 executes write of X, both write of X only. So T1 executes write of X and followed by T2 executes write of X. Then we can draw the edge. So in these three situations, we can draw the edges. So we can draw precedence graph in serialization. I think you understand the algorithm, right? Write operation, read operation, read operation, write operation, write operation, write operation, but not read. Okay, write, read, write, read, not read. Okay, so write operation, we are doing write operation in transaction T1, that means T1 executing write operation, then it is followed by T2 executing read operation. We can draw the edge. Next condition, T1 executes a reading operation, that followed by T2 executes write operation, and T1 transaction T1 execute write operation, that followed by T2 executes write operation. Then we can draw the edges. So this, based on that, we can draw the precedence graph. See here, in this situation we have only T1, T2. See, we have one table here. Based on that, we are going to draw the precedence graph. See here, T1 read the X. Okay, in T2 reading the X. So read. Then we cannot draw the so read will not be right. Read operation, write operation, then write operation. Check here. Here we are reading X. In T2 we have write of X. Yes, I have write of X. Now I can draw the edge from T1 to T2. Next is what? See, from T2 reading TY, reading Y, from T3 to T2. See here. See, we have X and Y, right? X and Y. So read operation, read write operation, write operation. There are none. Read Y and write Y. So I can draw T2 to T3. Then Then T3 to T4. Check this one. Read of Y and write of Y there or not there. Read of W. Read not. Read of W, write of W. Then I can draw T3 to T4. T3 to T4 I can draw. Okay. Next. Read of Z and write of Z. That means I can write T4 to T1, T4 to T1. I can perform in this way. So based on these three conditions, we can draw the precedence graph. Okay. So we have the problems also. We need to write the graph based on these three conditions. Okay. Please read these conditions. Then only you can draw the graph, precedence graph. So if you are executing the write operation in T1 transaction, that followed by the T2 executes read operation. Here read operation, write operation. Then we can draw the edge. Here in T1 we are performing write operation, that followed by T2, that is performing write operation. Write. So then we can draw the edge. In these three conditions only we can draw the edge. So then, as precedence graph is having the circle or closed loops, then given schedule is not serializable. That's what we can know from this precedence graph, serializable or not serializable. Okay. Okay, thanks for listening this session. We will see the remaining topics like these examples we can see in the next class.